Hello, everyone, and welcome to a new Code Us edition today. We have Jacob with us today, and everybody will be able to learn how to use a device image generation features in Starport and to be able to secure distribute their blockchain application. Hello, Jacob. Thank you
Hi.
for being with us today. I'll leave the floor to you. If people have questions during the event, please add them in the chat. And whenever we'll have a free time to make a pause, we'll address your questions in the chat during the event. So, yeah, let's start it.
All right. Hi. I'm Jacob, and I have been adding device image generation features to Starport, which is a scaffolding tool or a really, really fast way of building blockchains. And before I got into the code, which doesn't take too long, I wanted to touch briefly on why you might want to do something like this. One big reason is that current web server patterns that we can see kind of illustrated here involve a steady stream of user traffic going to a single API endpoint backed by many blockchain RPC nodes. That's a pattern that we use, for example, in the BLIRT community. It's also used in the Ethereum community to power the Infura endpoint. And as many of us know, that these occasionally run into problems. And one way to eliminate these problems and to really leverage, the unique capabilities of a blockchain is for everybody to have their own node. But of course, that comes with its own set of problems, right? Running a node in today's current state is fairly expensive. And, so you end up with this situation where an application can be centralized around, say, like a given domain name. This is a problem that we're trying to address at BLIRT. There are 5 major domain names, but quite frankly, you don't even necessarily want that. You might want to have a situation where a user can access the application directly from a node in their home. And the RPC server infrastructure, so that is this pattern here. And image hosting services. The more a thing weighs, and by weight, I mean like file size, less likely it is to fit on a blockchain, and the more likely it is to be shunted off to, say, some kind of S3 type service. Additionally, it's kind of tough to run nodes in your home right now. So IPv4, there are simply not enough addresses for the world's population. Because IP addresses are scarce in IPv4, there's a technology called NAT, Network Address Translation. And that puts a field of private addresses behind one public IP address. So usually that's your router is the public IP address, and then all the devices behind it have a private IP address. Also, in today's world, because you need to be in the cloud to have one of these public IP addresses, you end up paying too much for hosting. Just one example. Currently, I run just one of several BLIRT RPC API endpoints, and it's $150 a month for the 5 machines that back it. And if I wanted to expand that, the cost would go up in a linear way. If users ran their own nodes or clustered around nodes, so maybe they're one node for every 10 users, and they're sharing that interface, those economics change, and the application and the community actually become less centralized because of it. I think it's quite fair to say that in today's present state, almost everybody is not running a node. So, all right, that's the current state. And how does distributing a chain as hardware actually improve things? Well, the more users that have devices that have a fully synced node, that strengthens, the peer-to-peer network overall. And when you're shipping software as a device image, one of the things that you're going to see as we jump into this is that we can really, really tightly define the environment. Like, we can adjust every little setting and then distribute that to many, many people at relatively low cost. The Raspberry Pis I'm going to be working with today, each one costs about $50, memory card about $25. And then finally, when we get into rethinking the way these systems work, you can add an additional network layer. So in today's presentation, you're going to see zero tier, which is a flat virtual network that allows users to basically you're all on a private network. Okay, so everybody can connect to everybody directly, and this has both security and collaboration advantages. There are also a couple of security disadvantages too that we'll get into. So, all right, we have hit the meat here. What are we going to do? We're going to first scaffold an app. We're going to push that app to GitHub, and I'm going to actually talk through the GitHub Actions build. We're going to flash the app to an SD card, put it on a Raspberry Pi, fire it up, and actually start a chain and make one tiny little blog post. It is kind of a lot of software. Okay, you're going to need Node.js. You'll need the latest version of Go. You may want to have the GitHub CLI, mainly because that makes creating a new repository pretty much seamless. This Balena etcher thing is used for flashing the micro SD card flashing the image to the micro SD card. I definitely recommend it over like using DD. If you use DD, you may destroy your hard drive. All right, so I've been building against the Raspberry Pi 4, and you'll want one of these guys. Okay, there's my trusty USB micro SD reader writer, and an SD card greater than 8 gigabytes, or 8 gigabytes would probably be fine as well. So this next part is really kind of maybe just showing off Starport as well. I mentioned that Starport is a chain scaffolder. I think it also changes the economics of blockchain development in a pretty big way, because, well, just watch the speed. We're going to have a chain and a user interface in just a couple of minutes here. Okay, so when Starport compiles, what it does first, it builds a bunch of different Node.js dependencies. There's basically a node, both front end and back end setup in here, both written in Vue.js, which is delightfully modular. If you're a front end dev, or like myself, maybe not a front end dev, but would like to learn how to do more, Vue is really cool, because in each .vue file, you get your HTML, CSS, and JavaScript in like one little module. And what you're going to see as we go forward is that these modules actually map to one another, so that For example, a Cosmos SDK module that provides a certain API is going to map to a certain Vue.js module. And this makes thinking about your blockchain application a lot easier. I know there's some people here from the Blurt community, and like that would be, you know, one major difference between what you get when you're building with Starport and, you know, what we currently have with Blurt, which is pretty. The chain is more or less one file called database.cpp, and then you attack it. So here we go. We're not going to call this one Clay 4. All right, we're going to call it Clay 5. And Clay, some of you probably know this, is my name for an upcoming perma testnet. And it's basically where I want to like aggressively test out new technologies. And I think the big deal at this point is actually the zero-tier network. And so, all right, what this is doing is it is grabbing additional dependencies. And we have Clay 5 rolling. Also, the development branch may have changed. This could get interesting, guys. So, let's see. Yeah. There is. Aha, there we go. Okay. So we're defaulting to Launchpad now. And just so you guys know, for this demo, we're not going to use Launchpad. Launchpad is the version of Cosmos that supports inter-blockchain communication. And actually, as we are talking about, networks a lot. Well, I believe that this pattern that results in, hopefully, thousands and thousands of nodes scattered all across the world running hundreds of blockchains, is actually quite friendly to the way that IBC is designed and works. So, Launchpad. There. Okay. Now, what did we get? Well, what we just did, check this out. So if we just do this, what it's going to do, it's going to install any of the front and back end dependencies for the chain, and it will give us, well, it's going to give us something beautiful, but it's not going to have a blog, okay? And we're going to add a blog to it. What you're going to see is that this command here, really quite powerful. It allows you to add new types to your blockchain and also get scaffolded front-end components. Now, it's nothing fancy what these actually map to, right? Like post, it's a string. Oh, sorry, no, post is in the name of the type. Title is a string. Body is a string. And you could make it more fancy. And that's actually where Starport turns from like a scaffolding tool or a generator into more of like an application framework. Now, let's just check out what we've done so far. So we go here. We go here. Come on. There. And okay, so what do we have? We have a wallet. Might have been, yeah, it was in from an earlier session. Okay, and in here. Hey, look, we have money. Anybody who's here and familiar with blockchain development, you probably know this used to take a couple months at least, unless you're just forking something. And even in that case, it could easily take that long. So what are we gonna do? We're gonna send ourselves a little token for fun. 100 of them. Okay, and we're gonna add a message. Hello world. I sent it to myself. Believe that's all we're gonna get there. But I should. It's back a step here. Huh, okay. So, alrighty. We just built a chain with a wallet, but let's get into the hardware. So, where's that magic happen? Okay. In here are a couple of key files. What we've got, this view.service systemd service that starts the Vue.js front end. So it basically starts this, but on the Raspberry Pi. We have this pybuild.json. Okay, and this describes what goes into the image and basically copies things into the file system. And with no further ado, what I'd like to do is now we're going to hop into actually creating the image. Of course, adding blogging features. So here we go. See, I'm in .py. We don't want to be in .py. That would be bad. There we go. Want to be in Clay 6. And okay. So what this will do is going to add so you can see that all these untracked files here have been added. And that is basically everything that's needed to handle that post type. One of the things that this does is it provides a good reference to any programmer as to like where things should go. And another thing that it does is just save time. So now we're gonna gh login. We're gonna gh create repo create. Yeah. Make a nice public repository. Oh, and guys, don't skip git add. Okay, git add will add all those untracked files, otherwise they won't be there. And there we go. Otherwise, the build doesn't work. So now we can create the repository. There we go. And, you'll need this set upstream thing because it's the first time going into the repository. So all right, so we just pushed that to the master branch. Now we go to GitHub. Magic happens. So building these Pi images, it's really actually kind of a pain. To give you some idea, I've spent the past 4 or 5 days working to actually upgrade this image or this image build system. And the thing is, they have to be exactly right. But once they are exactly right, it becomes a repeatable process. And GitHub Actions allows us to, do this quite freely and with ease. So what's happening here are a set of discrete steps, which are controlled by this pi.yaml file. So this pi.yaml file was generated by starport just for this chain. Okay, so now there is this concept of a new chain in the world called Clay6, and it's on GitHub. Its binaries are being compiled in this fashion here. And we'll get CLI daemon uploaded. And finally, it'll go to here where it will take that Pi build file and actually copy the chain's binaries into a device image. Then it's going to shrink that device image down. And then it's actually going to provide us a place to download build artifacts. And now I want to hop over here and check comments and see, people's thoughts and ideas, and if anybody had any questions. Hey, how you doing? So, guys, if you have any questions at this time, it's probably a great time to ask them because, phew, oh, what failed? What failed? We can't have stuff failing. I see a red thing in the circle. Huh, that's weird. I totally saw a red thing there. All right, anyway. No more red thing, guys. Life's good. So what we're doing, right? Let's see. If I refresh the page, it'll probably give us sort of a blow by blow of what's going on in the image builder, but it's pretty, standard stuff. If you've ever set up an Ubuntu server before, all of that is happening, but inside of a virtual environment. That virtual environment is then taken and made into an image file, and you flash that image file to your Raspberry Pi. So anybody got questions or thoughts on this? If not, right, thing that I would actually like to talk about is where this goes. So right now, you're looking at a really beautiful text editor called Notion. Thing is, it's proprietary, and a lot of folks, prefer to use just open source applications. But open source has a tough time monetizing. Now, my colleague Alessio at Tendermint, he calls this open source plus. And what he means by that is, you get to build an open source application, and you get to monetize it. How are you monetizing it? Well, you're monetizing like the infrastructure. One way that this changes kind of what may be kind of a dark blockchain pattern, right, is that I'll kind of draw it out for you guys. So in the past, you might have had something like ICO, dev work, launch, and let's say financial shenanigans in between, right? But what if you had a pattern that was actually more like dev work, after the dev work is done, you would then be actually moving directly to Genesis. Okay, so Genesis, a new chain / app. And then you may be wondering, well, wait, how do you make money? How is it liquid? Well, lucky for everybody who does cryptocurrency a little bit more than, say, like casually, I think that end is near. Well, centralized exchanges won't ever end, but decentralized exchanges are getting really competitive. And there are several that are going to be launching in the Cosmos ecosystem. And so using IBC, interblockchain communication, right? You're going to be able to link your chain to several dexes. And kind of the pattern that I've discussed, haven't actually tried it yet, but I certainly intend to, for Genesis works a little bit like this. Okay, and then after then there's also like a to support ongoing. But of course, the hope is with any of these chains that you're building, really an extensible application platform, because you have all of these APIs available. One of the things that I believe changes when users get these devices in their hands is that they will be able to build directly against the API without any kind of intermediary or abstraction. I should probably just show you what I mean. So here we go. It's 3. Really? That's interesting. Wait. Do this live? That's crazy. All right, ready, guys? Oh, yeah, no, it's not interesting. I thought something had resolved, but it's not. All right. Down to that crazy thing. And not 3. Get rid of that. So what that was, just a known host file for SSH. And what we're doing is we are logging into actually an instance of Clay 4. And you don't want to log in as root. You want to log in as Ubuntu. Logging in as root will fail. Username is Ubuntu. Password is Ubuntu. Keep it simple, right? Okay, so this is an image that I generated earlier because I didn't really know exactly how long this image generation process was going to take and what the flow would be like. And it looks like the flow would be better if I just used this one that I baked up earlier. But it's the exact same thing that you would get from this Clay 6. So I'm going to ask you for your current password because it makes you change it right away. Oh, There. Okay. All right. So what happens when this boots? Well, a number of things. It automatically launches a web front end. Is that 3? Yes, it is. Okay. So here is Clay 4, and you'll notice it has the blog. But if we were to try and make a post, it would currently fail, and we don't have any kind of a key. So what do we do? Well, we need to start the chain. This is actually going to be automated in the future for chains that are already live. So if you'll bear with me, and it's explain deployment flow a little bit. For pre-Genesis chains, you're going to be using starport pi, which contains the starport binary. It's going to let you join chains to validate, and it is also going to let you build chains. So you have this nice little like self-contained blockchain development environment. This is an example of downstream pi. It's what's generated by starport when you make a new chain. And to fire up your chain, what you're going to do is like this. We're going to start a new screen. Okay, we are going to, let's break down this command too. Clay d init -- chain ID be like water testing. So testing being the moniker. Okay, it's like the sort of like a username, I guess. I should have came up with a better moniker, but hey. So yes. Okay, guys, another thing. It is a generator. If you name your chain Clay 4D or Clay 4, right? You're going to get two binaries, Clay 4D, Clay 4 CLI. When you use the Stargate version, that's the IBC supporting version, sort of like the up and coming version of Cosmos, you will just get a single binary and it'll do all those tasks, just baked it into one. So with no further ado, there's one thing we need to do. So I skipped a step in the docs, which is Clay CLI keys add validator. Oh, Clay 4. All right, and for the purposes of the demo, I'm going to do something a little unsafe. I'm taking this and I'm putting it directly in the Notion document. Don't do this in practice, please. But it'll allow us to reference these keys when we want to actually access the application. So, all right, what have we done so far? We have set up a key named validator, and now we're going to add a Genesis account. And that's 10 million of each. There. Okay. All right, and now we have the old Genesis transaction. So when we added the Genesis account, we added an account to a file called genesis.json. That corresponds to. Oh, I can't scroll because I'm. In a screen. There. So right here, okay, you see this account with 10 million stake, 10 million token, and what we've done, we just added that to the Genesis state. This is very simplistic. It's not decentralized. We're doing like a single node Genesis here. And it's the DVLID. There we go. Everything they tell you about a MacBook 2017 keyboard is true, and then some. There. Okay. Oh no, they didn't make the number high enough. So, should you flub this process, which is totally flubbable, and by the way, it's automated by Starport. What you would do is, and I did just flub it, and it's basically easier to just nuke the whole thing. And this is actually one of the patterns that Starport has eliminated. You notice that when we did that Starport serve, we did not need to get into this, and that's pretty key. we're totally just copying this. Apparently I can't put the right number of zeros. Okay. And there we go. Right, and this collects Genesis transactions in a decentralized start. Okay, this is traditionally done by like having a bunch of people actually upload Genesis transactions to a GitHub repository. One of the big differences here, now that we're using Starport, and now that we have these Raspberry Pis on a flat network, like, is that it would be possible to link these Pis together directly and actually not tell anybody that you're launching a blockchain. Thesis. Let's talk theory for just a second. I think that it's pretty likely that blockchain communities are going to just spring up and proliferate all around the world. They're going to attract different people for different reasons, and they are, there's an economy there. There's also a sense of like social, getting to know people, and there we go. We just Genesis a blockchain. Okay, now in later versions, what this is actually going to do, it's going to connect to a thing called Starport Network. It's going to grab the Genesis state that's already been prepared. It is going to sign it and get ready to validate instantly. And it'll be on its own network from the start, which means that, just for example, say you are developing or entrepreneuring on a blockchain, right? You can ship these devices to people and directly connect the individuals. You're building a stronger community, a stronger chain, stronger product by using this approach where your community is not mediated by a cloud provider. The current state of affairs, in my opinion, what it means is that, effectively most major chains could be knocked down by a cloud outage. So we got the chain up and we left that screen. Okay, we did the old Control A, Control D to get out of it. And now we just need to start an RPC, or sorry, and a REST client. So okay, and you like and the old LADDR, I think. Yes. Right. And for the LADDR, it's going to be the address of your Pi on the network. Okay. So, like, for example, and then unsafe cores. Otherwise, the web front end won't connect to it. Another thing, these things you're seeing now are actually being automated away. Earlier today, I released kind of a preview video of actually just that. But I still think that this is really quite significant because no missing port, so we'll give it a port, no problem. What you're looking at, it used to be months and months of work. Um, I can tell you guys, I imagine that some people in the audience know that I participated in like a governance change to Steam this year called Blurt, and I can tell everybody that was 3-ish part-time months of development, 2 people, and it's a solid 90% the original source code. So what this has done is created a setup where it's designed for you to be able to leverage that pre-existing code base, and in this case, right, the chain itself. So what pre-existing code? Tell me, I think I have though. I think I've put 2 mnemonics together. Let's try to sort that out. Okay. If I go here and I make we're using 12 words. So what we do, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. Pop this in. Okay. Maybe. So I did put unsafe cores. Hmm. Hmm. Maybe it wants a little HTTP in its life. I bet it does. That's my guess. Oh, is my VPN connected? 1 through 7. Ah, yes. Well, that's not fun. So the here's this. So guys, see we've got the RPC here. It's there's a setting here. Just a moment. We have 7 minutes. I'll take you through the settings. If you have any questions, let me know. And otherwise, what I'm going to do is I'm going to finish this out. I do believe that there is it's going to be /view. I put all of the front end stuff in /view. This is a systemd service. And well, it's called, we're running. There it is, this view CLI service. So we're going to that needs to be changed. And there we go. I believe it is about time to close up. So let's talk about what we got and where it's going real quick. Got about 3 minutes left here. What we've got is a system that automatically generates a front end and really clean. We've got a system that generates both a chain and a front end. Modules on the chain map to modules in the front end. And you also get the ability to distribute it as hardware, and those device images connect to a single global VPN network backplane. One of the biggest problems in building true peer-to-peer applications over the years is basically this. I hope you guys can see me. So I'm over here. Here's Alice and Bob, right? And they wish to talk to each other. Well, in the current state of affairs, Alice never talks directly to Bob. Instead, what happens is that my head here, right? My head gets in the middle. That's your WhatsApp, your Signal, or what have you. Okay, and with this network topology, because everybody's on a flat network and everybody can speak directly to each other, they can have immediate conversations with each other. And how? I just noticed that we had a question from how, and I'm sorry I didn't get to it earlier. How? Right now, the tests are limited to the Raspberry Pi, but trying the Odroid N2 and Amlogic, yes, that'll work. Rock chip, yeah, it'll work, but usually the rock chips take a little bit more configuration than the Amlogic. I don't expect it'll be hard at all. Basically, to support the Amlogic device, you do is go to Arch, Linux ARM, and Forms. You're starting from a different place. So where in today's video we were actually using Ubuntu, the next version uses Arch Linux, and you click ARM v8, okay, and these are all supported devices here. And it looks like, yeah, there's a rock chip 3399 there as well. I guess I've never really been a huge rock chip fan because maybe the support's not as great. I don't know. But Amlogic, yes, certainly these Broadcom CPUs. And we've also been doing some research into either developing or using a fully 100% open RISC-V CPU core. And it's maybe the last thing that I'll mention is actually open source and sovereignty. So the big difference here is that when your community is directly owning the nodes, directly operating the chain, you get a far wider distribution. This chain software that we put up, but this thing is ready to go. I have launched several test nets with this, also with different variations on the network. So behind net, but mediated by nodes in the cloud. So basically, you have some cloud nodes, but your validators all live behind NAT. Or you use zero tier, which allows them all to directly connect to one another. And what I'll be doing, cheated a little bit on that UI. I'll be posting a little video on YouTube that kind of shows actually the final intended state of the user interface there. And if you have any questions about how to use Starport, how to model a business that distributes a blockchain as hardware, how to make that profitable, well, I don't know because I haven't done it yet, but I think that I know, and I'd certainly, I'd be really happy to talk to you about that and help you in any way that I can. But I'm at an hour and 1 minute, and I just like to thank everybody so much for attending. and hope you have a great day. I'm going to head to bed. It's about 1 a.m. here. So, again, thank you very much. Catch you guys later. Bye. And let's see, do that maybe? No. See ya.